Planets are extremely faint compared to their parent stars. Since most stars look like tiny points through even the most powerful telescopes, how is it possible to discover exoplanets? If exoplanets can't be seen directly, then we need to use indirect ways to find them. Astronomers have developed several such indirect methods. Using them has resulted in 4,341 confirmed exoplanets to date, with a further 5,745 discoveries awaiting confirmation. Even though an orbiting planet is generally tiny compared to its parent star, it has enough gravitational pull to cause its star to wobble slightly. The result is that the star alternately speeds up and slows down by a small amount along our line of sight. This can be detected as a Doppler shift, meaning that the color of the star's light changes, first towards the red end of the spectrum and then the blue. A star's wobble can tell us if it has planets, how many there are, and how big they are. So far, 824 exoplanets have been found in this way. In fact, the first exoplanet in orbit around a Sun-like star was discovered using this method by Michel Maillard and Didier Queloz in 1995. In 2019, they were awarded a Nobel Prize for their work. When a planet passes in front of its star, it causes a drop in the amount of light we receive from the star. Bigger planets block more light and therefore cause a greater decrease in the intensity of starlight. Also, if a planet is further away from its star, it will take longer to complete its passage or transit of the star. Again, using this method we can tell if a star has planets, how many there are, how big they are, and how far they are from the parent star. So far, 3,306 exoplanets have been found by the transit method. Direct imaging is another possible approach to detecting exoplanets, but the problem is exoplanets are millions of times dimmer than their stars, so they're generally lost in a star's glare. To get around this, astronomers need a way to block the light coming from the star so that its immediate surroundings can be seen more clearly. The device they use is called a coronagraph. It consists of a combination of masks, filters, and deformable mirrors to reduce drastically the star's light. Using this method, planets that are 1 billion times fainter than their stars can be detected. Also, the light from the planet can be passed through a prism to study it in detail and reveal the makeup of the planet's atmosphere. 51 planets have been found so far this way. When a star directly passes in front of another star, the light from the more distant star is bent and focused. This is because the nearby star acts as a kind of lens, a gravitational lens. Over time, if we observe the light of these stars, its intensity increases and then decreases. However, if the nearest star has a planet, we may observe a small spike in intensity as the planet also bends and focuses the light. So far, 106 exoplanets have been found by gravitational microlensing. The technique has revealed that rogue planets which don't orbit a star are more common in our galaxy than previously suspected. We mentioned the Doppler method and how it can show wobbles in a star's motion due to planets. If the star is nearby and the wobble quite large, it may be possible to detect visible changes in the star's apparent position in the sky. Unlike with the Doppler method, astrometry doesn't measure color changes in starlight, but actual changes in the star's position. Astrometry requires extremely precise optics and is especially hard to do from the Earth's surface because our atmosphere distorts and bends the incoming light. Therefore, space telescopes are more suited to this method. To date, just one exoplanet has been found using astrometry. Each method of detecting exoplanets has its strengths and weaknesses. For example, while the Doppler method works for finding large exoplanets in close orbits, the transit method is better at detecting exoplanets that are very far away from us and in larger orbits around their stars. Microlensing is especially suited to finding rogue planets. Over the next decade, astronomers will find many more exoplanets. Using larger telescopes and more sensitive detection equipment, they also expect to be able to analyze in greater detail the light coming from these planets, to tell us more about their atmospheres and whether they may harbor life.